Starting from topics covered till now, we will review the last topic which we studied and then we'll discuss queue data structure, its operations, and then we'll discuss circular queue and its operations. Starting from introduction of data structures and algorithms, we studied array list, which is a static data structure, and then moved to linked list, which is dynamic data structure. After that, we studied stack as an abstract data type. As you know, stack is an abstract data type in which LIFO operation is applied, means the element inserted first is last to be removed. And the common operation of stack are the push method, which is to insert the element, and pop method, which is to delete the element. And the supporting methods were is empty to check whether the stack is empty, is full method to check whether there is space in the array in the stack, and the top method which returns the top element or top index as per needed. Today, a data structure which we will discuss is queue. A queue is a data structure in which FIFO operation is applied, means the element inserted first is to be removed first. Unlike stack, in which we applied LIFO operation, which was last in first out, the element which we inserted in stack at the end was first to be removed. But in queue, we apply FIFO operation, which is first in, first out. Daily life examples of queue are a line of people waiting for their turn at a bank, or a line of vehicles waiting for turn at a toll plaza, or a line of customers at cash and carry to pay their bills. Consider an example of bus stop where, in case of empty station, the person who comes first is also the last person in the queue. So the front and rear pointer will point to same person. In case a new person arrives, then the rear pointer will change and it will point to the newly arrived person. Same, if a new person arrives again, then the rear pointer will change accordingly. And when the bus will arrive, then the person who was pointed by first pointer will first enter in the bus, and the remaining person in the queue will wait for their turn. In this state, if a new person arrives, then again the rear pointer will change and it will point to the new arrived person. Now you must be able to differentiate the working of stack and queue. So in simple words, stack is an abstract data type in which only one-ended operation can be performed. Hence the elements are pushed and popped from only one end, and in queue both ends are open, but one end is for NQ and the other end is for DQ operation only. Now if you remember the operations of array list, we performed about 12 to 13 operations like insert at end, insert at start, delete from end, delete from start, insert after specific value, insert before specific value, delete after specific value, delete before specific value, etc. But to implement the stack, we selected only insert at end method as push method and delete from end method as pop method. And here in queue, we will select the operations of array list which were insert at end, which is will be similar to push method of stack, and delete from start, which is dequeue method. A queue is mostly used data structure in computer science field, as queue is used to implement the various tasks of operating system where scheduling is required. It would be a natural choice for handling the calls in a telecom company. A queue will be used if a printer is installed in shared environment, or it is also used in keyboard buffer and multimedia or multitasking environments. The basic operations of queue are enqueue, which is to insert the element, and the element will be inserted at the end of the queue, which is rear end. And the other operation, which is dequeue, is to delete the element, which the element will be deleted from front of the queue. And the supporting methods are isEmpty, isFull, and front method, which returns the front index or front value of the queue as per requirement. The queue can also be implemented statically and dynamically. Like in stack, we implemented stack in static data structure, which is array, and dynamic data structure, which was by linked list. So we can also implement queue statically and dynamically. For static implementation of queue, when the queue is empty, then both front and rear end are set to -1, as there is no index which is less than 0. So to represent the queue as empty, we will assign the value -1 to front and rear, so that we can check whether the queue is empty or not. While enqueuing we increment the rear index by 1, and for dequeuing we increment front index by 1. While there is only one value, when there is only one value in the queue, both rear and front index point at same index. And if we have only one value in queue and we apply the dequeue operation, then definitely we will reset front and rear both to -1 to show that the queue is now empty. So to implement the queue by static data structure, we used the classes so that we can create multiple objects as needed. So the class name which we in the example are discussing is renamed as QUE, as if we assign the name as Q, then most of the compilers give error, as there is already a class of stack and queue in different compilers. So for data members, we have a data member size, which is to represent the size of the queue, and a pointer queue is taken so that we can dynamically create the array to store the elements of the queue. The other two data members are front and rear, which will point the front index and rear index accordingly. The methods which are in public part are, first one is constructor, which is a default constructor. So we are which is by the name of the class, and we do not pass any argument in the default constructor. As usual, we are not passing the any argument in Q class for the default constructor. For the overloaded constructor, we are passing an integer value, which is for the size of the queue, so that a user, when wants to create the queue object, queue data structure, then he may assign the size according to his requirement. The other supporting methods are is full and is empty. Both methods return Boolean value. In case of the method is true, if the queue is full, then it will return true, else it will return false value. And the other method is empty, same returns true in case of the queue is true empty, and returns false if the queue is not empty. The other method, which are dequeue method, which is for to dequeue the element from the queue, and enqueue method to enqueue the element in queue. First of all, we are creating the constructor of the class. First one is default constructor. As we know, in default constructor, we do not pass any argument. So here we are defining the default constructor by using the class name with scope resolution operator, as these constructors or methods are defined outside of the class or boundary. So we have to use scope resolution operator. First of all, the size is assigned value 10. So when we will create the object by default constructor without passing any argument, then the default constructor will be called and the size of the queue will be 10. In next statement, queue is equal to new integer size. By this statement, we are allocating the memory at runtime. We are creating the array to store the elements of the queue, and the array size will be 10, as it is assigned the size is having value 10. Then we are assigning front and rear as -1, because initially the queue will be empty and there is no index which is -1. As the array starts from index 0, so the other value -1 means there is no value in the array. The indexes are outside of the bound of the array, so we know that this will be in empty case. Another one is overloaded constructor. In an overloaded constructor, we are passing the argument which is x, and x is for the size of the queue. Because in default constructor we are passing the size, so that if the user requires the queue as per his requirement, he wants to change the size of the queue, so he can pass the size argument in constructor, so that the queue size will be according to his requirement. Here we are assigning size is equal to x, the value which will be passed at time of creating the object, and the next statement in again we are allocating the memory at runtime for creating the array to hold the queue objects, and the size of the queue will be x number of indexes. Again, we are assigning front and rear to -1, as we know that if the queue, initially the queue will be empty and there is no index which is -1. So initially, to represent the queue empty, we are assigning front and rear as minus. Moving to supporting methods of queue, the method is next method is empty method. Is empty method returns true in case the queue is empty and returns false if the queue is not empty. So to check whether the queue is empty, we check that if rear is equal to -1. As we know that initially the queue is assigned -1 value, front and rear both have -1 value, as there is no index which is less than 0. So we assign by default front and rear -1 so that we can check that whether the queue is empty or not. If the queue is empty, then rear and front both will have -1 value. So if the rear value will have -1, then it will return true. That means the case is true. The method return true when the front or rear will have -1 value. So we are just checking rear rather than checking front and rear both. We just check here front is equal, rear is equal to -1. We can also check, we can also apply on this case on front, that if front is equal to -1, then again we can, its method is true, then we can return true. If rear is equal to -1, that means the queue is empty. Else, so we return true value in case the if condition is true, and return false in case the if condition is not true. Other supporting method is a full method to check whether the queue is full or not. So the full method, definitely to enter a new value in queue, we will check whether the queue in queue there is a space or not. If there is no space in the queue, then we can't enqueue any new value in the queue. So to check whether the queue is full or not, we apply same procedure like in case of empty, we were checking that whether the front or rear is having -1 value, then the queue is empty. So here we are checking that if rear is equal to size -1, while enqueuing, we reach at size -1 index. Assume that the queue size is 10. When the queue size is 10, as we know, in C language, starting index is 0. So first value will be at 0 index, second will be at 1, and third value will at 2, and so on. And when we have 10 values in array, then our last index will be 9. So the size variable, as we know, size variable will have the size of the queue. Then if the size is 10, then maximum index, rear index, can reach at 9. And if the size is 100, then maximum value of rear can be 99. So Same, we are checking if rear is equal to size minus 1. If rear reaches at size minus 1 index, that means the queue is full. So, if rear is equal to size minus 1, return true. That's mean it is having it have reached to that point where the queue becomes full. So simple. If rear reaches at size minus 1 index, then return true means queue is full. And if this condition is false, then definitely there is space in queue and we return false. Now moving to core operations of queue, which are NQ and DQ. To understand the NQ operation, just recall the example of a bus station or a line of customers. So consider a real life example of NQ. If I ask you to fill a glass with water, then my question is what you will do first? Definitely, you will check first whether the glass have space in that or it is already full. And when it is already full, then you will not pour more water in the glass, as naturally it will overflow. Same case applies here. If you have a queue size 5, then you can enter maximum 5 values in the queue. And if the queue size is 10, then you can enter maximum 10 values in the queue. So defining this method, first of all, the class name, which is QUE, then scope resolution operator, then return type, which is void, and then method name, which is NQ, and we are passing argument X as to NQ in the queue. So first of all, again, here we will check whether there is space in the queue or there is no space. So first of all, to check this, we will call the method spotting method, which is full. As we know, if we recall, is full method was if rear is equal to size minus 1. That means if you have entered the values from 0, then as we know that array starts from index 0 in C language. So if the queue size is 10, then maximum index of the queue can be 10 minus 1, size minus 1, which is size minus 1. So here in NQ method, we call the method is full, which returns Boolean value. In case if it is true, then it will display simply message that the queue, there is no space in the queue. So if there is no space, if is method returns true, then we will simply display the message there is no space and we will exit from this method. What if there is space? Definitely if is full method returns false, then that means there is space in the queue. So first of all, as we know, recall the example of bus station. If a first passenger arrives there, before him, the passenger, the front and rear were at -1, that there was no person in the queue. And when a first passenger arrives, then front and rear both point to that person. So here again, we are checking that if there is already a queue, existing queue or not. If there is already a queue, then we know the first and rear both will not be at -1. So to check this, we are checking this by if front is equal to -1, that means there is no element in the queue, as the array index starts from index 0. So there must be a value at index 0. So if front is equal to -1, then front is equal to rear is equal to 0. So as we know that if front is equal to -1, that means there is no value in the queue. If the front is not in -1, not at -1, that means it may be at 0, 1, 2, or 3 as per DQ, calling the DQ operation. So if the front is at -1, so we will simply change the front and rear, and we will change both front and rear, as both were pointing, having value -1. So the person arrived there is, or the value we entered in the queue, first value we have entered in the queue, is again first and last. Similar to that, if the person arrives in the queue is first and last, that means there is only one person in the queue, or only one element in the array or queue. So simply he is first and he is also last. So applying that concept, the concept there, we are again assigning front is equal to rear is equal to 0. Both will have point to the 0 index, as there is only one value in the queue which is at index 0. So assume that if there if the queue is not full, you call the NQ operation, and first of all, if is full method returns false, then you move to else method, which first one is if front is equal to -1. Assume that there is a value in Q. So if condition will will be false. So if there, that means there are elements in the queue. So as we know, if there are elements in the queue and there is space in the queue, we will simply change the rear operator and increment the rear operator. So after incrementing the rear operator, else operation, else part will end. Then we are assigning the value in at rear index. Q of rear is equal to x. As Q of rear is equal to x, so we are assigning there the value Q, value to Q at rear index after changing the rear, moving the rear by increment of 1. So that means first of all, if we check this, that means if we enter a new value, again we enqueue the method, we are passing integer x. First of all, if is full, then that means there is no space. That means there is no space. So this method returns false. So if it returns false, that means you are in else method. There the queue is not full. If the queue is not full, then you are at this part. So first of all, if front is equal to -1, then simply change front is equal to rear is equal to 0. What if you are at this part? If front is not equal to -1, so what you will do, you will simply increment rear by 1. So again there, check there. This is the part of if and else. After if and else I assign the value x to q. Why? Because if the queue is not full, then that means we have value. We have space in the queue. Then when we have space in the queue, we definitely will enter the new value. When we will enter the value in case of empty queue, or there are elements in the queue, we will definitely enter the value at rear index. So this portion is rear q of rear is equal to x, which shows that which is applied after the this operation, this method. As in case of empty, this one portion, or in case of not empty, in both cases we will assign the value at rear index. Now to explain the process of DQ, first of all we will relate this with real world example. If I ask you to give me a glass of water, then first of all you will check whether there is water in the jug or it is empty. So to relate this example with the implementation, first of all class name, then scope resolution operator, then DQ method which returns integer type value, as the queue is holding integer type of elements. So first of all, we will write the method is empty to check whether there is any element in the queue or the queue is empty. So is empty method is in previous slide, uh, when we defined the is empty method, it returns boolean type value. If rear is equal to -1, then return true, else return false. As there is no index which is less than 0. So in C language, first index is 0. So if an index is less than 0, that means there is no index in the array which is less than 0. So we call method is empty, which returns true in case there is no element in the queue, and we simply give the message that queue is empty. If the queue is not empty, if the value returned by isEmpty method is false, then that means the queue is not empty. Then what we will return? We will return the value which is pointed by front variable. So we will return front array of front, queue of front, which is first value to be dequeued. So after defining the enqueue and dequeue method and supporting methods, now we move to main method. In main method, first of all, we are creating the object of queue q1, which is named q. That name is q1. The q1 is a default is an object of queue created by default constructor. As we do not pass any argument as the constructor value, so by default the default constructor will be called. Another is q2 object, in which we are passing 5 as argument. That means it is an overloaded constructor. An overloaded constructor, as we defined overloaded constructor, and if you remember, the default constructor was that in which we do not pass any argument, and the size of the queue in default constructor is 10, and in overloaded constructor we are passing integer x as argument, and size of the queue will be according to the argument or value passed by the at the time of creating the object. So q3 q2 in q2 we are passing 5 value, which is that means the queue size will be of 5 to hold the 5 values of integer type. In Q3, which is also a type of queue, object of queue, we simply pass the value 15. That means the queue will be of 15 elements. So next in we are calling the methods defined earlier, like q1 dot nq, in which we are passing value 5 to nq, q2 dot nq7, and q3 dot nq6. In these methods, we are calling the nq method for q1, q2, and q3. All three are objects of q. So we can call again q1 dot nq, q7, q1 dot nq8, q1 dot nq15, or any other value. So we can maximum nq in q1 the value number of elements, which are 10, as the default size in q1 is 10. And in q2 we can pass maximum of 5 elements, and in q3 we can pass maximum of 15 elements. So in next, integer x is equal to q dot dq. That means we are calling the dq method in for the q2 object, and the value which is nq'd will be dq'd. In this case, we have nq'd only one value in q2, which is 5. So that means 5 will be dq'd, and uh, q will be, no, after dq the q will become empty. So we can call the nq or dq method with any object according to our requirement. So moving next to after discussing static implementation of queue, now we will move to dynamic implementation of the queue. As we know, for static implementation we used array, and for dynamic implementation we normally use linked list. So for in linked list we have implemented more than 15 methods for insertion, traversal, deletion, etc. And when we implemented stack dynamically, then we used the methods insert at end and delete from end. Insert from end was for push method, and delete from end was for pop method. So to implement the queue by linked list, for dynamic implementation of queue, we will simply use insert at end and delete from front method. So consider this one linked list, which have 5 nodes, number of nodes, and these 4 nodes are already in the linked list. So if we nq7, then this will be inserted at the rear of the queue. So that is insert similar to the insert at end method. And for dq method, we will delete the node from start of the linked list. So the node which will be deleted for this is this one. So after dq method, we will see the result is 12 is deleted, as 12 node, the node having the value 12 is pointed by front. So simply, if we write a method to insert at end, which will be as NQ method, and delete from front, which will behave like DQ method. We can also change this. Basically, our target is to apply the FIFO method, first in, first out. So if I change this as insert at start and delete from end, what do you think? Will this behave like Q or not? Definitely, it must behave. As now we have only two methods in our program. First one is delete insert at front, and other is delete from rear. Insert at front will be as insert at rear or insert at end, which will be as behave like NQ method, and delete from end will be as delete from rear, which will act as DQ method. So simply, our target is basically to implement the queue, which is FIFO. So if we apply the FIFO process by simply inserting at start and deleting from end, then again it will be a queue. So moving our next slide. Now we will discuss the problems which are faced by the simple queue. Using the array to implement the queue introduces the possibility of overflow if the queue grows larger than size of the array. As consider this one scenario. In this case, as you see, there are only 3 elements in the queue. Front is at 3 and rear is at 5. So we have only these values. Front is at 3 and rear is at 5 index, and the queue size is 5. So if the queue size is 5, queue size is 6. Now the queue size is 6. If the queue size is 6, then we can hold maximum of 6 elements. And the array, as we know, array starts from index 0. So our queue will start at index 0, and our last element can be at index 5, which is size minus 1. So now in this case, if you call the method NQ and pass any value, let's say x, and x is having value 3, so the program will return you the message that the queue is full. But we know that queue is not full, as these indexes from 0 to 2 are empty. But our program returns that the queue is full. So to handle this, what to do? Or we can change our program so that if we have empty indexes, then our program should not return the message that the queue is full. So there are two mechanisms. First one is shift the elements while dequeuing. Now let's consider this. In this case, we are having values 7, 5 and 2. So whenever we will apply the DQ method, these values will be shifted to start of the array. So that means after each DQ, we will shift all the elements of Q to 0 index. So that means first index value will, after DQ, the DQ will be applied on 0 index. So after DQ method, first one index value will move to 0 index, second index value move to first index, third index value will move to second index, fourth index value will move to third index, and so on. What do you think? Is this efficient? No, it's not efficient, as we have to shift each time when we apply the DQ process. So another solution is to implement this by circular queue.